Hopefully what we just talked about will help you as we go through this one. I think the complexity of this one is a little bit harder. Come up here, please. We're going to circle this, and this is a degree 3. This is a degree 3. That means at most, I can have 3 real solutions, 3 zeros. If there happen to be imaginary solutions, that'd be solutions that have i's, just know that imaginary solutions come in pairs. If you didn't know that, you want to write that down. Imaginary solutions always come in pairs, like 2i and negative 2i. Or maybe it would be 3 plus 2i, that would be 3 minus 2i, okay? Imaginary always come in pairs. All right, how do I know that there's no imaginary solutions for this? Because one thing I know is that if we have a 0 or an x-intercept, I know that the y value will be 0. Well, this is another way to write a y value. So I'm going to circle this, and I'm going to circle this. These are zeros. These are zeros. So if I have 2 zeros, and they're real, okay, they're real x-intercepts, then I know there's also going to be a third one. There can't be an imaginary one that goes along with this. I can't say there's 2 reals and 1 imaginary, because imaginaries have to come in pairs. So if it came in a pair, how many solutions would I have? 4 total, and how many is the most I can have? 3. So I know there's another one. Now I want you to analyze right now. I want you, before I even start this, I want you to analyze the y values. Remember how the y values change. If I go back to the last problem, you see how the y values change. When the y values change, what has occurred? An intersection on the x-axis. So let's watch. Okay, ready? Look at the y values. They're positive, positive. We hit 0, and then what do? We hit negative. Do you see how the y values change here? And does everybody see how there was a 0? Okay, let's come off from this side. We have negative, 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 and then we hit 0, and then does everybody see a positive? So can you tell me where is there another hidden 0 on this that they have not identified on this graph? Talk as a group. There's another 0 here that occurred, and you're going to tell me the range. It occurred between this x value and this x value. Go. Talk in your group. Between what 2 x values have we not identified on this table? Because it's probably not an integer value for x. Hands up high. I don't care if you're wrong. Hands up high if you think you know. Gabe, what do you believe? Yeah. 0 and 1 is correct. In between this range, there has to be another 0. And how do I know that? Because what's happening? The y values are changing. These are all multiplicities of 1 and it happens. Let's get started here. It says, part A, 2 zeros for the function g of x are specifically listed at the table. What are the 2 zeros and what are their multiplicities? So the 2 zeros would be, 1 0 is negative 1 0, another 0 is 2 0, and those are multiplicities of 1. Multiplicities of 1. It cuts straight through. With a multiplicity of 1, it's changing. That y value or output value is changing positive to negative or negative positive, vice versa. That's how I know it's a multiplicity of 1. Now, I feel confident that many of you know this. If it was a multiplicity of 2, would the y values change from one side to the next? It would not. Okay? Let's go to the next one. Let's determine the value of A, and let's determine the value of C. Okay, I would like you to come up here and go all the way down here. A value of C. The value of C is the y-intercept. Write that down. The value of C is the y-intercept. When you find a y-intercept, what is x always going to equal? 0. So look at the table. Do we already know what the value of C is for this problem? Yeah, what is it? C equals negative 4. I'm going to circle this and write y-intercept. So this is pretty cool. I'm going to write down h of x. Here we go. H of x equals, I don't know what A is. I don't know what A is. But I do know that C is negative 4. And I can figure out what A is as long as I know one factor. Josh could tell me one factor, and Davey could tell me another factor, and either way we can solve for A. Josh, what is one of the x-intercepts? Negative 1. So Josh, can you tell me how do I write that as a factor? Can somebody help Josh out? Because I know he gets this. X plus 1. Okay, what could be another one? Can somebody tell me if I chose it, like, I don't want to work with negative 1, what could be something else I could write down? Jose. X minus 2 would be another factor. How do I know they're factors? It's a factor if it's going to represent the x-intercept. So what we're going to do right now is we're going to do synthetic division. I'm going to choose to use negative 1. So I have A, 5, 4, negative 4, and what's the remainder? 0. How do I know it's going to be 0 for the remainder? because it's an x-intercept, I'm going to give you a chance right now. Ready, get set as a group. Ready, get set, and go. Some groups are doing a little better job than others and working together. Make sure you talk through this. Begin. You know what? I think there's even an easier way here. And that's always my goal in math. My goal in math is what is the simplest way to get the answer. Does everybody listen to that? I think there's a simpler way. Listen to this really quick. Stop, stop, stop. All eyes up here. Simpler way. I think we can choose one ordered pair, and let's choose the easiest one possible. And if we plug in a specific value for the x and the outcome for the y, the only variable we'll see will be a. This concept works, but when I'm thinking that we're dropping down a and we're multiplying and adding, it's going to work, but I'm thinking there could be a simpler way, and I don't even mind if we had extra time comparing the two. I'm going to choose any ordered pair. I'm going to choose 1, 2. So I'm going to choose 1, 2. It doesn't contain a 0, 1, 2. I'm going to plug 1 in for all the x's. I'm going to plug 2 in for the output, and let's see what I can do. So 2 equals, okay, 1 times 1 times 1 is 1. 1 times a is 1a. 1 times 1 is 1. 1 times 5 is 5. 1 times 4 is 4 minus 4. Okay, 2 equals 1a. 5 plus 4 is 9. 9 minus 4 is 5. I'm going to subtract 5 to the opposite side. I get negative 3 equals 1a. That means a equals negative 3. Now, we got to go back and think about if that's true. Okay, if a equals negative 3, what can you tell me about the end behavior of this? What's happening? End behavior. It goes down on which side? Down on the right, up on the left. So that means on the left-hand side, when I look over to here, past my last zeros, what should be the value of the y's? Positive. See how they are positive? Great job, great job. Okay. Between what two x values on the table does the other one exist? It's going to be between 0 and 1, and we've already spoken about that. Use the equation of the function to find the third 0. Okay, so use the equation of the function. So let's get started here. Let's start with the negative one. I know I don't have a lot of space here. Maybe I'll just do it right here. Here we go. Ready? Let's start with negative 1. We know negative 1 is a 0, so I'm going to do negative 1 first. We may have to do this a couple times. So here's my negative 1. And I'm putting in, we have, what was my a again? Was it negative 3? Negative 3, 5, 4, negative 4. Where am I getting that? That's the a was negative 3 and the c was negative 4. Okay, I'm dropping down. I got it. And then I'm multiplying to get 3, adding to get 8, multiplying to get a negative 8, adding to get negative 4, multiplying to get 4, adding down to get 0. Everybody good with that? Okay. Now let's see, is this factorable? Negative 3, so I'm going to rewrite this out here. I have no x's, I have 1 x, and I have 2 x's. Last time I made a mistake. Let me slow it down. Multiply to get 12, combine to get 8. What two values multiply to get, that'd be 6 and 2. Is everybody still in agreement? 6 and 2? Okay, so 6 and 2 multiply and they combine. So I'm going to drop down the a, drop down the c, and now in this area I'm going to put my 6x and my positive 2. Before I move on, I think I'm just a little nervous after making that first mistake. Does anybody disagree with me? No? Okay. I can factor out a negative 3x, and I'm left with x minus 2. Negative 3x squared plus 6x. Plus 2x, we get plus 2x minus 4. Okay, all of this looks great. They both contain an x minus 2. In the front is a negative 3x, in the back is a plus 2. So I could write it in fully factored form, and this would be my, if this is g of x, I think it was, right? This is my g of x. So what is the final 0 we have not accounted for? This is 1, this is 2. I'm going to set this equal to 0, and I'm going to solve. First thing I'm going to do is subtract 2 to the opposite side. Then I'm going to divide by negative 3, and I get an answer of positive 2/3. That is the third and final 0.